Algebra 1 video, section 3.3. In Big Ideas Math, it is function notation. That's what we're talking about. So, big ideas here are use function notation to evaluate and to solve, to use function notation to evaluate and solve, on an equation or on a graph. We're given an equation or given a graph. And interpret the meaning of function notation in context. We'll do one example like that at the end. Sorry, I'm talking a little fast. But let's get right to it. Let's say we have y equals 5x minus 8. And let's say we have f of x equals 5x minus 8. The only difference here between these is here we have a y, and here we have an f of x. This is read f of x. It's not f times x. In this case, anytime you see letter, usually like F, G, H, but I mean using a letter, and then parenthesis x equals or parenthesis other letter equals, it does not imply multiplication. It implies the function with this letter denoting what function we're talking about with an input of that. So function f with an input of x. So why do we use function notation? So some of the reasons we use function notation is it gives us more information than just y equals. So here if I said like y equals, let's say y equals negative 3, I could say f of 1 equals negative 3. Where here this is saying x equals 1, y equals negative 3, all in the same answer. Where here I'd have to actually write that out, x equals 1 comma y equals 3. So function notation gives us information about x when we're talking about the y's. And remember just that f of x is replacing the y. Another reason we use function notation is because that way we can use like two different functions. Like we could have a cost function, we can have a revenue function, and then we could talk about our profit. So the profit function equals your revenue function minus your cost function. And you might have to have multiples of these, or these might have, in the real world, these would have more than one input. Like, when you're running a business, your costs are going to depend on a lot of things, like how many people are working for you, how many hours, if you have any real estate, blah, 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 all the things that you have to buy for it. And then the revenue is all the money coming in. Depending on who you're selling to, what you're selling, right? It'll be more complicated than just one simple function. But each thing could be represented by put these inputs in, get these outputs out, and then profit is the revenue minus the cost. So this is better than y equals y minus y, right? So we don't have a name for them, or they're all just y's. I'm like, that's not very wise, right? Like smart wise, like an owl's wise. Okay, bad joke. Let's move on. Let's evaluate and solve using function notation. I'm going to erase this. And we'll do some actual algebra stuff with solving and evaluating. And by algebra stuff, I mean just stuff where there's numbers in it. That feels more algebra-y, usually. So let's say we have this function f of x equals 7 minus 2x. And let's say we have this function g of x equals 3 over 5x, 3/5 x, plus 1. Let's go ahead and evaluate f of 5 and g of 20. And then let's solve for f of x equals 11. And solve for g of x equals 7. Go ahead and pause your video right now and just write that down on a piece of paper so you can work along with me. So pause it and come back. Hopefully you paused it, or you've got it written down already. Okay, evaluate f of 5. What this means is find when x equals 5, what's the answer? What's the y number? So what we do, say, well, f, this is the f function, this is a g function. We want the f function. So, okay, well, x is 5. Well, it's going to be 7 minus 2 instead of times x times 5. So that's 7 minus 2 times 5 is 10. So it's negative 3. So we write f of 5 equals negative 3. And that's it. Boom, got it. Cool. Let's look at the g function. So here we go. It's g of 20. So this means when x equals 20, because instead of an x, there's a 20 there. So we're like, all right, well, it's 3/5 instead of times x times 20 plus 1. Okay. Well, we've got a fraction here. And remember, a fraction is a division problem in disguise. 3/5 is 3 divided by 5. So we can either go 20 times 3 and then divide by 5, or I can go 20 divided by 5 and then times 3. So that's what we're going to do, is we're going to go 20 divided by 5 and then times 3. In this order. 20 divided by 5 is 4. 4 times 3 is 12. So here I get 12. Yep. And then plus 1 is 13. So we say g of 20 equals 13. So both of these are evaluating. Notice it's f parenthesis number, f of number, g of number. The x has been replaced by a number, so you replace the x with a number. Let's move to the next part now. So here, let's get a different color. Where's my purple pen? There's my purple pen. Aha, got it. We are going to solve when f of x equals 11. So this means find the x value that makes f of x equal 11. So in other words, what input, what number do you replace x with to get an answer of 11? And the way we figure this out is you say, well, this is f of x is 11. So I'm going to take where the f of x is, and I'm going to replace that whole f of x. This whole thing is what 11 is equal to. So I'm going to go 11 equals 7 minus 2x. And then I'm just going to solve that, right? We said f of x equals 11. F of x equals this. Replace the f of x with the 11, because that's what it is. I'm going to go minus 7. Minus 7. I get a 4 equals negative 2x. Divide by negative 2, right? Because it's negative 2 times x. Divide by a negative 2. X equals negative 2. And we can write our final answer as f of negative 2 equals 11. That's answering the question. It's saying f of x equals 11. What's the x? Well, f of negative 2 equals 11. The x number is negative 2. I think on the homework you can just give it to us as x equals negative 2. I think the textbook actually asks for that, but I don't remember. They're both correct. All right, let's look at the g problem now. All right, we have g of x equals 3/5 x plus 1, and we want to know when g of x equals 7. So once again, right, is g of x equals, right, we don't know the x. So what this means is find the x value that makes g of x equals 7. So what we're going to do here is we're going to replace the g of x, this thing, with a 7. We're going to go 7 equals 3/5 x plus 1. This number's not going to turn out, well, it will turn out, that'll be nice, yeah. It'll turn out great. It will. Like, okay, well, we got to solve this. So we're going to go minus 1, and we get 6. 6 equals 3/5 x. And now I need to undo multiplying by 3/5. Now remember, multiplying by 3/5 means dividing by 5 and multiplying by 3. Top number of a fraction is a multiply, bottom number of a fraction is a divide. So I'm going to do the opposite of that. I'm going to divide by 3 and I'm going to multiply by 5. Or I'm going to multiply by the reciprocal, the reciprocal of that fraction. So 5 over 3. We multiply that on both sides. So I get x left over equals 6 times 5 is 30. 30 divided by 3 is 10. So x equals 10. We could have gone 6 divided by 3 is 2. And then 2 times 5 is 10. That works too. And we would say g of 10 equals 7. There we go. That's our answer. We got it. Cool. All right. Let's do a couple more just to make sure we really have it down. More examples never hurt. You can always fast forward if you're like, Mr. Rice, I got this, no problem. All right? If you're like that, then just fast forward. It's a video. Or you can maybe talk real fast by going like speed up to 2 times and make it take half as long. All right, let's say we got a new function. F of x equals 4 plus x over 3. So f of x equals 4 plus x over 3. What's the difference between this? So, sorry, excuse me, pen is still working. So find the value of x. Oh my goodness, f of x when x equals 11. And find the value of x. This is it. Find the value of x when f of x equals -6. Let's interpret what each of these means. So find the value of f of x when x equals 11 is just saying replace x with 11. So we're going to say f of 11. This one is saying find the value of x, not f of x, x, when f of x equals -6. So here we're going to replace f of x with a 6. All right, let's go ahead and do each of these. Pause it and do it. Just pause each try. And we're back. Hopefully you just didn't just wait for that awkward pause. So here we go. 4 plus x, but instead of an x, we have 11, because it says when x equals 11. So 4 plus 11 over 3. Well, remember when it's a fraction, there are implied parentheses in the numerator. So it's like 4 plus 11 first, so 15 over 3. 15 over 3 is 5, so we say f of 11 equals 5. Woo. Cool. Let's look at when f of x equals -6. So here, f of x equals -6. We want to know the x value. So we're going to replace the f of x with a -6. And we're just going to keep this 4 plus x over 3 as is. Now I got to solve. We're going to solve this. So I just work backwards. Multiply by 3. I get -18. Because 3 and -6 multiplied to -18 equals 4 plus x. Subtract the 4. We got a negative minus a negative. It's getting more negative. -22 equals x. All right, cool. Let's talk about some graphs. It's going to get graphic here. Let's say I have this graph of f. 1, 2, 3. 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. 1, -2, -4, -6. All right. And we're going to start here. Y-intercept at 0, -2. And we're going to have a slope of 3. Let's say we've got that line right there. And this is the function f. So now we're given f, instead of as an equation, we are given f as a graph. So we want to find what is f of -1. And when does f of x equal 4? Well, we can look back at what each of these things mean. So here, f of negative 1, this means when x equals negative 1, what's f of x? And remember, f of x is our y value. So all we got to do is be able to interpret, like, hey, this means that x is negative 1. Well, let's find where x is negative 1. That's right here. This is x equals negative 1. The line x equals negative 1 is this vertical up and down line. And we see, as I go up and down from negative 1, I hit the graph right there. Boom! Right there. And what's the y number here? It's at negative 5. So, f of negative 1 equals negative 5 because the point negative 1, negative 5 is right there, is on the graph. So the answer here, f of negative 1, is negative 5. Now, let's look at this. F of x equals 4. Well, remember, this is find the x value, or solve for x. In other words, we don't know the x. The x number we don't know, which means we know the y number. The y number is 4. So we go to 4 on the y-axis and we say, aha, here's 4. And we draw the line y equals 4, which is a horizontal line. Everywhere on this line, y equals 4. And I go down, I'm like, oh, what x number? 2. So here, x equals 2, so I say f of 2 equals 4. Boom! All right. So that's how that's one example. We'll do another example, and hopefully that'll help with evaluating a function by looking at its graph. Let's say we've got different functions. Make this the g function. Why? Because g is a different letter than f. That's the only reason why. Let's say we go negative 1, negative 2, negative 3, negative 4, negative 5. A point there, and 1, 2, 3, 4, 5, 6, 7, 8, 9. And we get a graph that looks like this. Woohoo! All right, cool. With these points on it. So this is our g function. This is the graph of g of x. Now, let's say I want to know g of negative 3, and I want to know when is g of x equal to positive 4. Let's look at g of negative 3 first. So g of negative 3 is saying the x number, because normally it's g of x, and instead of an x there, we've got a negative 3. That means the x number, x is negative 3. So I go along my x-axis until I hit the number negative 3. And I say, all right, where does this graph, this curve, intersect x equals negative 3? Right here. And what is the y number? The y number is not up or down, it's just 0. So here, I'd say g of negative 3 equals 0 because we have this point, negative 3 comma 0. All right, now we're going to look at g of x equals 4. So remember here, we don't know. We don't know what x is. We don't know. But we know y equals 4. So I go to my 4, y equals 4 right here, and I just draw a line. Everywhere here, y equals 4. So I say, what x numbers on the graph give me y equals 4? And I get 2 of them. This should be a negative 1, sorry. Right here at negative 1. And right here at negative 5. If I drew it properly, it'd be at negative 5. We've got the point negative 5 comma 4 and negative 1 comma 4. So we would say g of negative 1 equals 4 and g of negative 5 equals 4. Or we would say x equals negative 1, x equals negative 5. Both of those are our solutions. Okay. let's call it good for that. That's the stuff you're going to get assessed on. We'll talk about interpreting function notation in class. This video is getting a little long and I don't want you to get burned out. So this will help you on both 3.3 homework assignments. And remember, I've got office hours if you have questions. Thank you for watching if you made it this long.